And so in order to explain these effects, whereby we seem to have, we seem to systematically believe that some exemplars are good members of a category or more representative, more typical members of a category, whereas others aren't, a different theory was proposed, referred to as the prototype theory of categorization. And the idea is that we categorize items using not quite a list of things that you either you have to have, and if you have them, you're in. If you don't have them, you're out. But rather, we have a list of characteristic features, things that typically make up a certain an exemplar of a certain category. And the more of these features you have, the more typical you are of that category, the fewer features you have, the less typical you are of the category, the less a good example you are of that category. And see, this would explain why, if you encounter a dog that has no fur, or a dog that doesn't bark, or a dog that doesn't have a tail, or a dog that doesn't have 3 legs, you'll still recognize it as a dog, no problem. According to the classical theory, if a dog had no fur, well, tough luck, that's not a dog. So this theory, the prototype theory, gives you more flexibility. It's not quite a list that you have to have. It's more, there's a set of characteristic features. And the more you have, the more likely you are to be inside a certain category. Now, the idea in this theory is that throughout your life, you might encounter certain dogs, and in your mind, you kind of generate this average dog, the prototype of what it takes to be a dog. And in the sense, it's an abstract representation. It's not a real dog. It's not necessarily a real dog. It's typically some kind of average imaginary dog. And the idea is that next time you encounter something that moves, that moves around you, you compare it to your prototypes. And if the new exemplar that you're seeing matches sufficiently the features that make up this prototypical dog, then you will say, well, that's got to be a dog. Interestingly, under this theory, the individual exemplars that you've seen don't play much of a role in your ability to categorize new exemplars. Now, there's a number of observations that are consistent with this view. For one, it really does seem that we tend to treat cognitively typical items in a different way than atypical items in a category. So for example, if I just were to ask you, well, tell me all the birds you know, you would start by listing the more typical ones, and then slowly you would start going towards the less typical one. So even this already tells you, and this is a fairly systematic finding, so our minds clearly value typicality within a category. Plus, if I were to give you, tell you or show you some exemplars and ask you to categorize them, the more typical they are of a certain category, the faster you will be at categorizing it. Furthermore, you can actually show that you can typical items can exert priming, whereas atypical items do not. Let me explain. There's a task referred to as the lexical decision task, which is what you're seeing here on the side. Now, in the lexical decision task, as a participant, you're just asked, you're shown, strings of letters, and all you have to do is decide as quickly as you can whether the string of letters that you're seeing is a word or a non-word. And see, what is interesting is that if you put here a typical item, of a certain category, if the next string of letters is also a word from that category, people will be faster at saying, yes, it is a word, compared to if you had a non-typical member of the category, that will not prime you to be faster when you see this word here. And remember, all you're saying is this string of letters a word or is it not? So if the preceding word is a typical member of a category and the following one is also a member of that category, people are faster at responding. compared to if the preceding word is not a typical member or if it's just a non-word. So very clearly, our mind treats differently typical instances, typical exemplars from atypical exemplars. Now, before continuing, let me ask you this. I'm going to show something on screen. I want you as quickly as you can to name it. All right, as quickly as you can. Ready? 3, 2, 1. Did you say cow? And the reason I say that is because when you show this to people, 95% of the times, what they say is cow. And see, what is odd is that you could have said an infinity of other things. You could have said it's a mammal, you could have said it's an animal, it's a quadruped, a tetrapod, it's a mature female bovine. You could have even have called it, it's Maggie Moo, right? Yet, you said cow. And in fact, it turns out, I could show you many other exemplars, and I can always have a pretty good guess at what you're going to say. See, the idea, which is an important aspect of this theory, is that individual items can belong to multiple levels or hierarchies of categories. Typically, when we categorize things, we tend to categorize them at their basic level, also referred to as their natural level. So when I showed you the animal and you said cow, the reason I knew you would have said cow is because you responded by categorizing it at its basic level, at its natural level. Now, for example, in this case, for this, the natural level is dog. For this, the natural level is apple. And see that the basic or natural level, it tends to be the level at which we talk about things. It's the one that provides just about the right amount of information about the category to be useful, meaning to be informative when you're talking with someone else, and to easily allow to distinguish something from members of other categories. So it's distinctive in this sense. So this is the most cognitively efficient way of talking with other people about an item. Now compare that instead to the so-called subordinate category. Now this tends to be a more precise type of category. Often instead of having just one word, like these, tends to have multiple words. And the idea is that these are extremely informative, meaning you can be very, very precise. They provide a lot of information about the item, the exemplar that you're looking. But in a sense, they're not as distinctive because different members can be very similar. Just for example, Granny Smith apple is not too different from other type of apples, right? So in this sense, when you're talking about items at their subordinate level, they tend to share a lot of features with other items. However, there might be contexts where it's more appropriate to talk about things at their subordinate level. Typically, this tends to vary with expertise. If you find yourself with a number of experts of apples, you're not going to say, well, that's an apple. You're going to say, this is this kind of apple or that kind of apple. Sort of there's a context for using different levels. And finally, the superordinate or supraordinate level of categorization, which in this case would be animal for the dog or fruit for the apple. And see, supraordinate categories tend to be distinctive, but not too informative. Knowing that something is an animal, as opposed, right, this sort of doesn't provide a lot of information compared to knowing that something is a dog, right? It's not informative in that sense. However, it makes it very distinctive. It's very easy to distinguish an animal from a piece of fruit. So these tend to be different levels at which we categorize items. Now, again, the typical at which people tend to talk about and tend to naturally categorize things tends to be the basic. There might then be good reasons sometimes for talking about the subordinate, talking at or categorizing at the subordinate level or categorizing at the superordinate level. Now, we're talking about the prototype theory. Is there any evidence that we actually do this? Again, the theory says that, in your life, you encounter a bunch of exemplars of some category, and then you slowly extract from that a prototype, and then you carry around forever inside your mind this prototype. And every time you encounter a new exemplar, you use the prototype to categorize the new exemplar. So is there any evidence that we do this? Is there any evidence that we extract prototypes? Now, in 1968, a classic experiment by Posner and Keel, known as the random dot pattern experiment. So what they did, in fact, let me show you what they did. They did this. They created some random patterns of dots. You're seeing one here. They created this and they say, let's call this prototype A. Okay, so this is a prototype. And then from this, they created a number of so-called distortions, which are nothing but exemplars. See, if you look at this, it's kind of very similar to this, except, let's see, this dot here got moved out, right, to here. And then this dot here got moved down to here. So essentially, we have a prototype, and we create exemplars that are similar to the prototype, but slightly different. So this is one, and then there's another one, and another one. And in this experiment, they created, for every prototype, they created 12 exemplars. And then they took also prototype, they created prototype B, C, and D. And for each of those, they also created 12 different exemplars, okay? So you create 4 prototypes. From each of those, you create a number of distortions or exemplars. And then the task is that I'm going to train you using the exemplars. I will train you to recognize group A, which are these, from group B, which are the exemplars or distortions derived from prototype B. And then I'll show you groups, and then I'll teach you to distinguish those from group C and from group D. Importantly, I'm never going to show you the prototype. You're never going to get to see this one. All that you will see are the exemplars. And so I'll train you for some 20 minutes until you become good at recognizing exemplars that come from group A, from group B, from group C, and from group D. Now, once we do that, I will test you. And the way in which I'll test you is the following. I'll now show you something, and I'll ask you to categorize it. For example, I will show you all the distortions or the exemplars. These are the exemplars that you've just seen and that I've trained you on. I'll show you this, and you'll have to say, oh, that is group A or group B or group C. Then I'll take the 4 prototypes and I'll create some new distortions, some new exemplars that you've never seen before. I'll show it to you, and I'll see if you can still kind of tell what family it comes from. And then, in fact, I'll even show you some new other distortions that are even kind of more distorted, sort of, there's more distortion with respect to the prototype, and see if you can still classify them. And then I'll show you the prototype. And mind you, you've never seen that prototype before. So to you, and you have no idea it's the prototype, right? To you, it's just one more exemplar, right? I know it's the prototype as the experimenter, but you wouldn't know. Now, turns out, when people see the old distortions, those are the distortions that you've studied, right? People do pretty well. 87% of the time, they can categorize them correctly. If you show them the new distortions, those that I didn't train you on, people are not as good, 75%. If you show them the new distortions, the even more distorted one, people are also a little bit worse. What is so interesting is that if I show you the prototype, and remember, you've never seen it before, and you have no idea it's the prototype. To you, it's just one more distortion, one more exemplar. If I show you the prototype, actually, people are very good at recognizing it. To them, it's the same as the distortions, as the exemplars that they have studied. So this suggests that people are extracting the prototype, because when they saw the prototype, which they had never seen before, to them, it's as if they had already seen it in terms of their performance. Look, these 75% is how well they recognize new ones that they hadn't seen before, that they hadn't studied. The prototype, instead, they recognize it 88% of the time. So it's They recognize it just as if they had seen it. So this suggests that somehow participants probably did infer a prototype out of the exemplars that they studied. So this is good evidence that in our mind, we are inferring prototypes. However, you might also notice that contrary to the prototype theory, participants are doing very well at remembering the individual exemplars that they have seen. Whereas the prototype theory says that the exemplars, you kind of forget those. They're not a big part. They don't stick much in your mind. You just use them to create the prototype, but then you sort of discard them. These exemplars don't play a real role. So this clearly is showing that although it is absolutely true that we extract prototypes, we're not quote unquote forgetting all the exemplars that we have seen. So those must play a role in our mind. And in fact, there are other intuitions that also go against the prototype theory in the same way. For example, context effects are not really explained by the prototype theory. See, the idea with context effects is that if you're in the US, a mourning dove is the most typical bird you can think of. So if you were to ask me what's a typical bird, to me, it kind of looks like this. I see plenty of these all the time. However, if you were in Australia, a rainbow lorikeet, just like this one, very typical bird. In the US, of course, this wouldn't even make the top 10 of the most typical birds. So in this sense, the individual exemplars that you and I are exposed to in our life do play a role in creating what is typical of a category and what is not. So it cannot be that we see the exemplars and we derive from them a prototype, but then we forget the exemplars. Because this by itself would not explain why we get these kind of effects. Plus, again, typicality effects. How would you explain, if the prototype theory is correct, how do you explain when you get very atypical members? Right? How could a penguin be considered a bird if indeed we would compare it to prototypes? Very few people grow up with penguins around all the time as birds, and yet we recognize penguins as birds. So it cannot be that all we do is that we extract from the exemplars that we find a prototype and then just use that in order to categorize new exemplars.